All right, this is the third stage of the third lecture in the Spring and Loop Theory series. That is the website if you wanted to go and check out the full explanation, the full concept, Spring and Loop Theory. Today, I wanted to sort of review a little bit, and then I wanted to do a bit more new stuff. So, we talked about the idea that there are loops, and there's a spring matrix, and that a loop contracts the spring matrix in the vicinity of the loop. I think I haven't really talked about what is the spring matrix. I think that I have the ability to talk about what is the speed of light, and it relates to this spring matrix. I think the speed of light is the propagation time through the matrix. So the reason why this ball is significant is, what is the propagation time when this ball hits this ball? How long does it take before this ball comes out? So we'll just watch it, and it seems instantaneous. But there is some amount of time. I don't know what it is, but some, few thousandths of a second or something like that. It takes time, once this ball hits, for another ball to come out. And so I'm saying the same thing is happening in the universal matrix of springs, is that when one spring is hit by some energy, it transfers it to the next one and the next one, and it transfers it through the matrix. This is why we can see light across empty space. It's being propagated through these springs. So, talking about what is the speed of light, I haven't heard anyone else do it. It falls naturally out of this theory. The Big Bang. Spring and loop theory has caused me to be skeptical about the Big Bang. One of the things I'm most skeptical about is they have this issue where space seems to be uniform and expanding everywhere. There doesn't seem to be any center, called the horizon problem. So my question is, if there was a bang, there should be an explosion in the center, and we should be able to say this is where it started and exploded out from here. And there's just no here in this universe that we have. With my springs, these energetic springs, I say that these energetic springs are hitting each other constantly. And they are gradually hitting each other and going apart. If you put a whole bunch of super balls in a bag, and these super balls were energized like these, self-energized, and the bag was gossamer thin, it was like a weather balloon bag, let's say, after a while those balls would make the bag get bigger. It's absolutely a natural consequence. So I think that the expansion of the universe is caused by these springs colliding with each other. Now the Big Bang has this issue where it's supposedly an explosion. They have just a number of issues, and so they created the idea of there's an explosion and then there's an inflation period where things happen very rapidly. You might say everyone gets in place very quickly and then life carries on. And this is out of necessity because the temperature in the universe is very uniform. Throughout the whole universe, temperature is very uniform. And if you have an explosion, the one thing you don't have is uniform temperature. So this is where the traditional explosion theory just is absolute rubbish to me. And this is a much more intelligent, because basically this says these are energized springs, they're energized all the time. Think of it like boiling water, and with boiling water it's gradually expanding, if you will. Maybe not a perfect analogy, but better certainly than the Big Bang theory. One of the things about spring and loop theory is that you start to be able to see some connections that weren't there before. We're starting to get some extra information. If the spring, what I call the bump speed, is the speed of light, and if we have some idea of how powerful these springs are, earlier I had sort of estimated, tried to go from memory of how powerful they are. Strings, according to string theory, the strings are 100 billion times smaller than a proton, that's 10 to the 20, and yet they're 10 to the 20 times more energetic. And so now we have how energetic these things are, and then we have a time of how long does it take for the light to travel through the system. And I think that starts to make it more feasible to calculate how big these things are or how far apart these things are. And we're starting to get some properties of these springs through this theory. The cosmic microwave background. Well, if you say there's a bang, and yet the space is 2.7 degrees Kelvin, how come? And they say, well, that's the residual temperature from the Big Bang. My intuition says 15 billion years after an explosion, you don't have any temperature. That's it, period. And it just doesn't make sense. 15 billion years, you're going to see some temperature. That's a fire. The fire goes out, but 15 billion years later, you can measure some heat from the fire. I think that when these springs are banging against each other constantly, as I maintain they are, and they're doing it everywhere all the time, that creates heat. That is your 2.7 degrees Kelvin. It's the background heat from these springs going all the time. Another interesting thing I just read on the 148 question Wikipedia page on the greatest problems in physics, and it was talking about how there's a space roar, and this roar is 6 times louder than it's supposed to be. It's 6 times louder than calculated. Well, again, this is just one of these many problems in physics. They calculate something and oops, it's not what they calculate. How come? They don't know why. Well, it seems reasonable to me that these things that are ultra energetic, imagine 10 to the 20 times more powerful than a proton, and basically 10 to 20 times more of them because they're much smaller, 10 to 20 times smaller. Isn't it possible that that could make some noise? I mean, remember I said that these interactions are almost like a nuclear bomb interaction. They're so energetic. Maybe they're even more energetic. And if you have all these, things going on, even in the vacuum of space where there are no air molecules, and sound only goes through air, it makes some noise, despite that, just because it's so darned energetic. And now, I wanted to sort of do the finale, and the finale is that I think with spring and loop theory I can start to say what are the 4 forces. The 4 forces conventionally thought of as the strong force, the weak force, electromagnetic, and gravity. Strong force is the gluons in a nucleus of an atom that keep the atom together. The glue, easy to remember. And the weak force is the weak gauge bosons and something else, I think, that they say it's mostly involved in radioactive decay. So if you have a nucleus and it decays, the weak force is involved. So radioactivity, like the nuclear bomb dropped in Nagasaki, Hiroshima, was a weak force exploiting the weak force, not the strong force. And I suppose the nuclear fusion, the next level up from fission, is the one that's probably tapping into the strong force. I'm not certain about that. So those are the 2 nuclear forces. They get weaker as you get away from the nucleus, and physicists have always said, why? I'll show you why. Third one, electromagnetism. That's electricity and magnetism unified by James Clerk Maxwell. He unified those 2 forces. I took my last name because of Mr. Maxwell and what he accomplished. I changed my name. So electromagnetism, that's the force that we see everywhere. Think of it like, like the bloodstream of life. It's absolutely everywhere, and everything we do, everything, we can't do anything without it. And things like when you see light, when sound propagates, and all these different things, they're all doing it through the electromagnetic force. So consider it the most well-known, the most common, the most easily understood. In the time of Einstein, I don't think that even Einstein knew about, at that time, about the strong and weak force. All he knew about was the electromagnetic and gravity. And even then, Einstein was bothered yet. The electromagnetic force and gravity, and the 2 were not unified, and that bothered him. I'll show you how they're unified. So finally, the 4th force, of course, is gravity. So this is what spring and loop theory says. The strong force that glues the nucleus together, what is it? It loops. It's a spring looping around the loop. That is the strong force. It's the strongest of all the 4 forces. It is the most fundamental bond in the universe. because it's taken the most powerful thing, a spring, and it's binding it. So naturally the strong force is the strong one. And naturally it's a gluing force. It makes total sense. The weak force is not hard to think about, not hard to imagine when you think, okay, we have a loop and a spring system, a building block system, and that's an atom. What happens when you break it apart? You know, the analogy I use is if you have a weightlifter and he lifts the weight up and then he drops it, that is the weak force. So it takes a great amount of energy to lift, 400, 800 pounds some of these guys can lift. So think of that energy as a strong force. The letting go of it, and when it hits the ground, when it hits the mat, and you kind of don't want to be nearby. You can probably see chips of wood or whatever the base material is made out of kind of flying because there is some force involved there. They're dropping the weight and you want to get out of the way. But it's nothing like the force that was required to lift them in the first place. And sure enough, the weak force is, as they say, they say it's primarily related to radioactive decay. So when you have these super strong things coming together, when they let go, think of it like a fire hose. This thing lets go and it's going to fly around until it grabs onto something else, right? And in that process of flying around, that's the weak force. Electromagnetism, electromagnetic force, getting back to this universal matrix, I say that this is everywhere, and I say that everything that propagates through this matrix, everything that bumps its way through it, of all the different frequencies and energies, is electromagnetism, is the electromagnetic force. That's why it's everywhere. That's why everything we do sort of requires that force, because it's like living in water, and then you would say the electromagnetism in water is like maybe viscosity, the stickiness of water. The stickiness of water affects everything that's in the water. When you try and travel through water, that viscosity slows your boat down more than it does in air, a great deal more. So viscosity kind of dominates water, let's put it that way. So the gravity is the subtle one of the four. No wonder it hasn't been, sort of figured out. No wonder they have so many theories. No wonder they are looking for gravity particles, which is ridiculous. Because it's an effect. It's a subtle effect of taking this spring and tying these two springs up with one loop. It's a subtle, small effect. But, and this is something that's testable and simulatable. If the universal matrix is like a fence, the loop string interaction here is like clamping part of the fence. If you hook up sensors at the ends of the fence, and then you clamp part of it, you will feel a gravity effect here. It will slightly compress that fence. Or maybe a better analogy, instead of a fence, because a fence is not exactly all dimensions, might be a fishnet. If you took a giant fishnet, sort of tensed it out, and if you just compressed part of that fishnet and then measured the effect everywhere, I think you will find it is a gravity-like effect, a slight effect on, and this effect propagates. This spring is contracted close to the loop. It means this spring is also sort of drawn. He has more space, so he tends to go this way towards the space, and this one tends to go this way, and this one tends to go this way, and that's a slight attractive force. So there are the four forces. Notice how they are all tied to one force. They're all related to, you have loops, you have springs, so the strong is the spring binding, the weak force is the spring letting go, so it's the same force there. The electromagnetic is you have all these springs of energy, these S's are these springs of energy, and everything, all interactions are related to these springs of energy bumping and transmitting these bumps through the spring matrix. So once again, the springs are central to the explanation. And then finally, gravity is finding a way to contract part of this matrix of springs, and what's the effect of that. So unification through this theory. Finally, in the realm of things this theory doesn't explain, one of them I'm sort of puzzling about is what is the neutrino? And I think that, if you recall initially I was talking about gas, liquids, and solids in chemistry, and how the high energy, the gases of my system are the springs, the liquids are the loops, And maybe the solids are the neutrinos. That's why they're weakly interacting. That's why they can go through a light year of lead and only 50% of them get absorbed type thing. Is that maybe a neutrino is a ball. And if you notice, you have springs and loops, you get a strong bond. Well, what happens when you have this system and you have a ball? Think of it like a cannonball. And there is talk that neutrinos are quite a bit smaller. And I forget the numbers, but in essence, what if the neutrinos are smaller than these bundles of energy, these springs of energy? Wouldn't it be easy to imagine them just simply, passing in or around these larger objects? Let's say these are trees in a forest. And what if the neutrino was a bullet? You can imagine it avoiding the trees. And so that's just something to think about, just to show that spring and loop theory is not trying to claim that it understands everything. And also, what I'm trying to say is that there's a great deal of uncharted territory. There's life that we understand well. There's some bigger stuff we don't understand as well. There's very microscopic stuff that we understand very poorly. And as an order of magnitude problem, it's like saying we manage our own finances well. When it gets to the national debt, we've definitely got issues. But when it gets to the micropayment system, a Bitcoin-like system or some other, PayPal or some other micro system, we're really out to lunch. And we really have no idea what anybody is doing. And we have to accept that. That has to be built into our physics, how it's taught and how it's portrayed. Because otherwise, right now on TV, we get this, isn't it all wonderful? We've got it all figured out. This is how it is. And let's just marvel and go, oh, gee, I'm so dumb, and this is all so wonderful and smart and profound. It's not quite so clear-cut. And I think if we taught it in a way that said, this isn't all known. We have theories, and our theories are getting better, but it isn't all known stuff. And I think if we taught that way, people would go, well, then maybe I can carve out a niche. Maybe I can figure some part of this out. And that would be a bit more, less of an exclusive club, and a bit more encouraging to everyone to learn a bit more physics. So, Spring and Loop Theory, there it is in a nutshell. There's the website, and thank you for listening.